fascinating lab experiments, we have decided to test two simple harmonic motion equations. We will be comparing t equals 2 pi root m over k and the variation of Hooke's law, mg equals kx. We aim to test the validities of these two equations. Let's go over the materials we'll need in no particular order. 5 different springs, cart and mass, inclined plane, stand and clamp, meter stick, horizontal rack, mass scale, tape, Logger Pro and motion sensor, textbooks, Yanni's swag, Raphie's handwriting, and Chia-Hua's brain and calculator. And his lack of senioritis too, I guess, since he's the only junior in our group. Anyway. Step 1. Weigh the cart and mass. Set up the spring according to setup diagram A. Step 2. Open Logger Pro. Pull the cart along the inclined plane down at a constant length. Use a meter stick to check. Release the cart and let it oscillate. Step 3. Using Logger Pro, record the oscillations. Use the graph generated to estimate the period. Step 4. Using t equals 2 pi root m over k, calculate k. This is the Ka value. Step 5. Repeat steps 1 to 4. Generate 5 trials per spring. Average the Ka values. Alternatively, you can average the periods, then find Ka. This latter one is what we did. Step 6. Hang the spring vertically from a rack. Measure the length of the spring. Step 7. Hang the mass and cart at the bottom according to setup diagram B. Measure the spring length again. Step 8. Using data from steps 6 and 7, subtract the unstretched length from the stretched length. This gives us delta x. Find delta x and use mg equals kx to find k. This is the kb value. Step 9. Using ka and kb, find the percent difference. You can use the formula, percent difference equals the absolute value of kb minus the average between ka and kb over the average, times 100%. Step 10. Repeat the experiment with 4 more different springs. Congratulations! You've gotten through the most painful part of the lab. You can now analyze the data you got. For the spring we showed in this video, we got 8.1% difference. We can attribute it to many different errors that occurred. Some of them include measurement errors of the vertically hanging spring, which changed the kb value, the spring itself having mass, which changes the Ka value, and the spring being deformed in the process of our experiment. Since the percent difference is quite small and can be easily blamed on experimental errors, we can conclude that indeed, t equals 2 pi root m over k and mg equals kx are both valid equations. They yield very similar spring constant values. Thank you for watching. I hope you learned something from the #1 physicist in the world. Just kidding, but we do have swag.